Hello everyone. Welcome to 5-Minute Knowledge. As of now, humans have only set foot on the Moon, a natural satellite of Earth. No other planet in the solar system has been directly explored by landing missions. So, what prevents humans from landing on other planets within the solar system? NASA's Apollo missions in the 1960s and 1970s were the only manned missions to date that successfully landed humans on the Moon. These missions took approximately 3 to 4 days to travel from Earth to the Moon. Specifically, Apollo 11, the first mission to land humans on the Moon, took about 76 hours over 3 days to travel from Earth to the Moon. Unmanned missions like NASA's Lunar Reconnaissance Orbiter LRO or China's Change missions also took about 3 to 4 days to reach the Moon. NASA's New Horizons mission, launched to explore Pluto and the Kuiper Belt, crossed the Moon's orbit just 8 hours and 35 minutes after launch, but it was not intended to land on the Moon. Therefore, the average travel time from Earth to the Moon with current vehicles is typically about 3 to 4 days. The cost of a manned mission to the Moon has been significant. Conducting manned missions to distant planets like Mars would be much more expensive, requiring massive financial resources and extensive international cooperation. Sending humans beyond Earth always entails significant risks. Journeys to other planets take months, even years, increasing health and safety risks for astronauts. Harsh conditions on other planets also pose major challenges for sustaining human life and work. These factors together make sending humans to other planets beyond the Moon a long-term and complex goal, requiring substantial efforts and advancements in space technology. In the case of humans landing on other planets within the solar system, we have considered many factors, but upon summarizing, we focus on analyzing two main obstacles affecting travel and landing: the distance of these planets from Earth and the climate of each planet. So, how far away are these planets from Earth? And how long does it take to reach them? The time it takes to travel to other planets in the solar system depends on several factors, including the distance between Earth and the target planet at the time of launch, the speed of the spacecraft, and the chosen flight trajectory. Below are estimated travel times based on previous manned missions. Mercury. Distance from Earth, approximately 77 million km, 48 million miles at closest approach. Messenger mission, it would take about 6.5 years to reach Mercury due to its complex orbit around other planets to reduce speed. Venus, Mariner 2 mission, it took about 3.5 months to reach Venus. Distance from Earth, approximately 38 million km, 24 million miles at closest approach. Mars, Viking 1 mission, it took about 9.5 months to reach Mars. Distance from Earth, approximately 54.6 million kilometers, 33.9 million miles at closest approach. Jupiter, Galileo mission, it took about 6 years to reach Jupiter. Distance from Earth, approximately 588 million kilometers, 365 million miles at closest approach. Saturn, Cassini mission, it took about 7 years to reach Saturn. Distance from Earth, approximately 1.2 billion kilometers, 746 million miles at closest approach. Uranus, Voyager 2 mission, it took about 8.5 years to reach Uranus. Distance from Earth, approximately 2.6 billion kilometers, 1.6 billion miles at closest approach. Neptune, Voyager 2 mission, it took about 12 years to reach Neptune. Distance from Earth, approximately 4.3 billion kilometers to 0.7 billion miles at closest approach. Generally, except for Venus and Mars, traveling to planets within the solar system would take from 6 years to 12 years. Regarding weather conditions, we find that planetary weather is the most challenging factor preventing humans from setting foot. So, what is the weather like on each planet? Let's continue exploring. Mercury has no atmosphere, resulting in extreme temperature shifts from -173 degrees Celsius at night to 427 degrees Celsius during the day. Its surface features volcanoes and is very dry, making landing challenging due to high temperatures and lack of atmospheric protection. Venus. Venus has a thick atmosphere primarily of CO, causing a powerful greenhouse effect, resulting in surface temperatures around 465 degrees degrees Celsius. The atmospheric pressure is very high, 92 times that of Earth, with sulfuric acid rains. With extreme temperatures, high pressure, acid rains, humans cannot land on Venus with current technology. Mars has a thin atmosphere, mostly of CO, average temperature around -63 degrees Celsius, with a dry, desert-like surface and frequent dust storms. There is frozen water at the poles, despite challenges with harsh conditions and thin atmosphere. Mars is the most feasible target for exploration and potential human landing in the future. Jupiter, as a gas giant, Jupiter has no solid surface. Its atmosphere consists mainly of hydrogen and helium. With large storms like the Great Red Spot, temperature decreases inward. It's impossible to land on Jupiter due to lack of solid surface and toxic atmosphere with extremely high pressure. Saturn. Similar to Jupiter, Saturn is a gas giant with an atmosphere of hydrogen and helium. It features prominent ice rings, strong winds, and large atmospheric storms. Landing on Saturn is impossible due to lack of solid surface and harsh atmospheric conditions. Uranus, a gas planet with primarily water, ammonia, and methane. Uranus has a cold climate with an average temperature of about -224 degrees Celsius. It has methane clouds and strong winds. Landing on Uranus is impossible due to lack of solid surface and extremely low temperatures. Neptune has the coldest climate in the solar system, with temperatures around -214 degrees Celsius. Its atmosphere is mostly hydrogen, helium, and methane, along with strong storms and winds. Landing on Neptune is impossible due to lack of solid surface and harsh climate conditions. Thus, considering the two factors of distance and climate of each planet compared to Earth, we understand why, since humans last set foot on the Moon on December 11, 1972, we have not set foot on any other planet. So the new question is, what do we need to prepare to successfully land on the planets outside the solar system, specifically Mars? We will provide the answer in upcoming videos. Please like and subscribe to stay tuned for exciting new videos.